Jetpack Compose is a powerful toolkit for building user interfaces in Kotlin. It was created by Google as a modern approach to UI development for the Android platform. Shortly after its release, Compose Multiplatform was created by JetBrains as an extension of Jetpack Compose, which brought support to desktop and then eventually iOS and web applications. For simplicity's sake, I'll be referring to both of them as Compose since they're functionally the same, but with some small caveats that we'll discuss later. And in this lesson, I'll be demonstrating everything for you in a multi-platform project using Android Studio. If you'd like to follow along, you can download the empty project file in the description, or you can just sit back and enjoy the video Nat Geo style. So how does it work? Well, at its core, Compose is centered around composable functions, which describe your UI. These functions are marked with the @composable annotation, and within them you have access to all sorts of pre-built UI components, as well as any other composable functions that you create. To get a better understanding of this, let's take a look at the anatomy of a simple Compose application. First thing you'll notice is that we have a function here called app. This is going to serve as a wrapper for our entire application. Inside of this, we're going to call all of our other composables, such as the various screens of our application. And since this is a multi-platform project, our app function is defined here in the common main directory, where it can be shared throughout our entire project. If we take a look in our platform-specific directories, we can see that all we're doing is calling this app composable from all of our main entry points. So now that we have an idea of what this app function is, what do we actually put inside of it? Well, the next thing that you will usually see is some sort of a theme composable. In this case, we have the default material theme. This is another wrapper that provides anything inside of it with access to a set of default colors, shapes, and fonts. And of course, this can be customized to your liking. I'll make an entire video on how to set up custom themes in the future. But for now, just know that it's not mandatory to include a theme, but it is useful and the default values provided are good enough to start with. So we have our app and our theme wrappers, which is a great start, but how do we actually create a UI? Well, let's take a look at some of the most basic composables and how they work. For example, we might want some text in our app, and for that we have the text composable. If we hover over it, we can see that this function accepts a bunch of different parameters. For now, all we'll worry about is the text parameter. So inside of our function here, we'll say text equals, and then we'll pass in the text that we want to display. Let's keep it traditional and say hello world. I would like to point out that all composable function names always start with a capital letter. This is just how Compose works. Okay, so let's run the app. And there it is. We can see that the text appears on our screen. Let's add another text composable and see what happens. I'm going to duplicate this line with Control D, and I'll change the text here to something sensible like subscribe to Max Dev. Let's run this and see what happens. That's pretty weird, right? Well, what's happening here is that basically we've told Compose that we wanted two text elements, but we didn't tell it where we wanted them to be. So by default, they're just drawn right on top of each other at the start of the screen. So let's take a look into some ways that we can control the layout of our app. First up, we have the column. The column is a composable that, as its description says, lays out its children in a vertical sequence. This means that your composables will be placed vertically in the sequence that they're called inside of your column. So let's move these text elements into this column and then run the app again. Now we can see that the text is no longer overlapping itself, with the second text composable being drawn below the first, as you would expect. However, our text is still all crammed up into the corner here, so let's figure out how to deal with that. This is where parameters come in. As I mentioned, composables are just functions, and most functions accept some sort of input as a parameter, right? Well, composables are no different. Let's hover over where it says column and take a look at its parameters. We can see that it accepts a modifier, some arrangement and alignment values, and it also accepts a composable function called content. By the way, see how these parameters are followed by an equals something? This shows you the default values that the function will be run with. However, not every parameter has a default value. For instance, we can see here that content is not provided with any sort of default value. This means that it's mandatory for us to provide the content, while the other parameters are optional for us to include. And in our case, we've actually already provided the content right here. By default, Compose knows that whatever you put in curly brackets after the function name is the content for that function. Now let's take a look at this modifier parameter. Modifiers are a way of customizing any given composable to your liking, For example, you can use a modifier to change a composable size, its background color, or even add animations to it. Nearly every single composable accepts a modifier, and you will get very familiar with them. I'll do a whole deep dive on modifiers in the future, but for now, let's just experiment with it a little bit. I'll start by adding a custom modifier to this column like this. Right now, this is actually the same as the default value that the function runs with. To change that, we'll add a dot after the modifier, and we can see a big list pop up of all the different things available to us. To help us visualize what's going on, let's start by setting the background color. So we'll say modifier dot background, and we'll pass in any color that we want. We can say color dot, and we'll see a list of default colors pop up. And also, since we're inside of this material theme, we could also say material theme dot color scheme dot, and now you can see that it also has a bunch of options available. I'm going to set this to color scheme primary for now. Keep in mind that the primary color is usually used for highlighting important things, but I'm just going to set the background equal to it for now so that we can really see what's happening. Let's run the app and check it out. So we can see that our column is actually just a tiny rectangle around our text. And that's because by default, a column is going to wrap around the contents that it contains. However, what if we want this column to fill up the entire screen? Well, we can do that easily with the modifier too. We can actually chain multiple of these dot functions onto our modifier. So here where it says dot background, after that, we'll just add a dot fill max size. An important thing to note here is that these are function calls and they will happen in the order that they're written in. In this case, it doesn't actually make a difference whether we call the dot background or the dot fill max size first, but it will be important down the line, so I just want to mention it now, but we will cover that in more detail when we take a deeper look at how modifiers work. For now, let's run the app and see what happens. Now we can see that the column is filling up our entire screen, but the text is still up in the corner. If we hover back over the column, we can see that besides the modifier, it accepts those vertical arrangement and horizontal alignment parameters. And we can see here that they default to arrangement.top and alignment.start. In Compose, the start of the screen is the left-hand side and the end of the screen is the right-hand side. So that means that by default, any content in the column will be placed starting at the upper left-hand corner. But what if we want our content in the center of the screen? For that, let's try passing in our own arrangement and alignment values. So I'll add a comma after the modifier and I will say vertical arrangement equals, and here I'll say arrangement dot, and we can see that a list of arrangement options pops up. I'm going to select center. We'll add another comma here and then say horizontal alignment equals, and here we'll say alignment dot, and we get a list of options. Here I will select center horizontally. Now let's run the app to see if it worked. And it did. Our column now fills up the whole screen and our text is centered. I'm going to change this color from primary back to a more appropriate color like background, and I'll run it again. So this is the basic flow of how a Compose UI works. You will typically have some sort of layout composable like the column here, and it will contain a bunch of smaller composables like the text. And in many cases, the smaller composables will also have their own layout, which has its own subcomposables and so on and so forth in this sort of nested fashion. And doing this, you can create some very interesting, very complex layouts for your application. Although typically you wouldn't actually design your screens inside of your app composable as we've done here. Instead, you would define your screens in their own separate composable functions. So for the last portion of today's lesson, I will show you how to do just that. This time, for organization's sake, we're going to define our composable in a separate file. I'm going to make a new directory inside of this common main Kotlin folder, and I will name it presentation. Then here, I will create a Kotlin file, and I will name that something like my screen. Now we can define our function here. We start with the @composable tag. Then below that, we can write function myScreen, and then we're going to give this function a single parameter, which we will call modifier, and we'll give it the type modifier. Of course, Android Studio went ahead and pre-populated that for us. We can also give this a default value by setting it equal to modifier. And just for example, we can add the .fill max size here so that our default modifier will fill the whole screen instead of wrapping around the content. Now let's go back to our app composable and we will cut out this column and its contents. And now let's paste this into our screen composable. Next, let's remove all this right here and replace it with lowercase m modifier, which as you can see is the one right here from our functions parameter. Now back in our app composable, let's call my screen. Let's run that and check it out. And as you can see, it works. It's the same screen that we made earlier, but neatly packaged away into its own separate file and function. And this is where we'll leave it for today's lesson. Just a little taste of how things work in Compose. But you will definitely want to stick around for the next episode where things are going to get cooking. We will dive into how to add state into our composables so we can handle things like user input. We'll take a closer look at modifiers and more. So if you are interested in that, then hit the like button and subscribe so that you'll be notified as soon as part 2 comes out. As always, thank you for watching, and until next time.